And also, with this refraction, it always bends down, right? Light, they tell us, but actually, wouldn't refraction go each way?
Well, I have only ever experienced it. I'm like going, not down. I
Up.
All my observations, yeah, that I can show anybody, show it going, up every single time. It's either
So
clear. It's either
every
like a clear.
measurement you make, like actual measurement, right, shows you the light refracting upwards.
Well, I can say because all my observations are using water. Okay,
Right.
like
Okay.
they're across water. So all I
So
can say is
specifically over water.
water over water. It's always upwards. I've got all my observations show that, all of them.
Yeah.
Amazingly, the following scientific information about refraction in the lower atmosphere has been around for many years, yet for the most part, it somehow never found its way into standard surveying practice. Most recently, a 2010 Geophysical Research Journal article came to this conclusion. Our results corroborate that the Gaussian refraction value of plus 0.13 is not suited for describing refraction effects in the lower atmosphere. They determine the opposite refracted curvature. For example, this gradient that you see the formula here, derived from practical temperature measurements by Hens 2006, translates to a local refraction coefficient of minus 2.9 compared to the Gaussian value of plus 0.13. This describes not only a stronger but also a concave curvature of the path of light, that is, opposite to Earth's curvature. The link for the paper is here. Here's a link. I'm gonna post this link in the description for you guys. Refer also to the paper Investigation of Refraction in the Low Atmosphere from 1969. There's another link I'm gonna post for you guys. On the first page of the paper, the author notes that Gauss derives his positive coefficient of 0.1306 in 1823, in contrast to the long accepted Gaussian value. Note the reality of high negative K values for midday listed in tables 1 and 2 in the 1969 paper, as high as minus 1.62 for a height of 1 to 2 meters above the ground. What's important here, of course, is that light is bending not with the curvature of the Earth, but the other way, against the supposed curvature of the Earth, meaning that this explanation that has been put forward by defenders of the globe, that light is bending according to the curvature of the Earth with gravity, is literally bogus, because people are measuring the exact opposite of this proposition. Also see pages 118 to 121 of the book, The Climate Near the Ground, on Google Book Search. I also have this link for you here. Check out the wild fluctuations of the K value throughout the day and night in figure 18.3. An older edition of that book is online here. And here's another link that you can follow up on, all in the description. Note the high negative temperature gradients listed in table 13 on page 84 of the older edition. These values are obtained from measurements at Salisbury Plain in southern England from 1923 to 1925. A calculated K factor in the range of 1 to 2 meters height above the surface at 2 p.m. in July works out to about minus 1.2, consistent within the range of values in the 1969 Hungarian paper. A professional surveyor undertook some measurements across Lake Michigan, which he documented in this video. And here's a link again. However, his data are inconclusive since he didn't consider refraction. His equipment was set up on the beach dunes in the mid-afternoon, so a highly negative temperature gradient most likely existed with a corresponding concave refraction. In another video of his, he mentioned, starting at 11:10 in the video, anecdotal evidence from local people who had viewed the Sears Tower across the lake near sunset. Here's another link. That suggests refraction effects may have been close to nil at that time of day. And now that people have been using infrared filters to take photographs, we have a different situation. We don't see that much refraction, and we can see much farther. So I guess you can bypass the whole discussion of refraction if you have a filter that makes that go away. He continues. On his website, Andrew T. Young makes reference to documented cases of distant mountain sightings from extremely long distances. Distance to the horizon. How far can you see? And here's another link. Such reports date back over a century ago by highly credible individuals. However, the reports are discounted as being either optical illusions, after images and such. In my opinion, those sightings were most likely possible because of no curvature. And he follows with another couple of emails. A Master of Science thesis was undertaken in 1987 which documented significant concave refraction during the day for gravel, grass, and asphalt surfaces. The PDF link is here. Propagation of refraction errors in trigonometric, height, traversing, and geodetic leveling. Link also in the description. Section 531 describes the equipment used to measure temperature gradients that were necessary for calculating K values. This is a graph I created from the data listed in table 5.6 of the report. We're looking at changes in the coefficient of refraction at 1.5 meter above asphalt surface and different days, different times a day. And it fluctuates. See figure 5.3 in the report, which gives contours of K values for all three types of surfaces throughout the 2 days. The K values are only positive, convex, during the late evening and early morning hours. Zero refraction occurs in the transition phases from plus to minus and minus to plus. In this post, clueless Mick West was trying to demonstrate his knowledge of how refraction is used in surveying practice. Based on his notion of a technical literature review, he concludes that the methodology hasn't changed in 200 years. Just keep using the one-size-fits-all K equals plus 0.13 Gauss fudge factor, blissfully unaware of more recent studies to the contrary. He added a screenshot of Mick West posting his video. And here he is claiming that refraction explains how you cannot see the curvature, you cannot detect it, and how the light is supposedly bending. But of course, we just saw how that is not even true, what he says about refraction and how it varies during the day, and the positive versus negative values are actually underrepresented. It's usually negative refraction, and with periods of positive refraction, which are smaller. You can see here clearly that for most of the day you have negative refraction, meaning the light's bending away from the supposed curvature of the Earth. So the idea that gravity is bending light is absolutely proven wrong by these measurements, and these are corroborated by other measurements by other people working in the same field as recently as 1987, as Aetius has pointed out. If you're following what's going on in the movement, you know that Dr. John Dee has already issued a video going after Mick West, proving that he was lying or being deceitful or being dishonest. And it's funny that people somehow choose to think this person is worth listening to. It's surprising to me. Obviously, he doesn't know much what he's talking about, and people who are experts in light optics and refraction are just showing how he's just incorrect according to the science that's available, of course. And this is why people who are honest come out, like Aetius, and point out these contradictions. even though they are not coming out to take a stance that there is no curvature and you cannot detect it, because they're afraid of the social consequences, as you will see here. Continued from previous emails, here it goes. You guys may want to obtain the freeware program MicroDem. It has powerful features for line of sight and 3D perspective viewing based on digital elevation models. It's a bit buggy though, with occasional crashes, and he sends the link. I'm going to post you the link. The program has algorithms for Earth curvature and no curvature. All these links will be posted. The above link has typos using lowercase k. It's supposed to be uppercase K, meaning radio K with microdem. See another link for information. I'm reproducing all these links, of course. I also recommend that you read Professor Gutt's paper using DEMs to register oblique photographs and web cameras. Another publication. And I would point out right away that we have people making models such as Iro Landucci, who's made fantastic models, also taking into consideration atmospheric effects that he can do in, I think, Cinema 4D. And he has shown how, for instance, with the atmosphere, you will perceive a sun going down the horizon even though it is on the same altitude going away from you. He has shown that to be the case through atmospheric refraction and by modeling this in a very careful and detailed and effective way. So there are people doing all kinds of things with modeling. Here's his suggestion. And we're going to get a little bit of information on what he does. But he's not going to reveal who he is. And he says, I've been using microDEM to generate 3D DEM perspective views, both for flat Earth and theoretical Earth curvature, to compare the results to actual photo or video images recorded at various project locations that are posted on the internet. To compare apples to apples, I used zero refraction to analyze pure terrain geometry. What I found was that without refraction, neither the flat Earth model nor the curved Earth model match photos for any cases. Recently, Ito has shown how you can do this with the program that he uses, where you have a view that shows you the flat plane without the effect that you get from a lens. And in that case, it would not match reality. But as soon as you add the lens features to that rendering, it really starts looking like what you get from cameras. And cameras make what is flat curve slightly. We had recently some people who have been attacking researchers in the flat Earth movement claim that you could take a photograph in a given altitude and compress it sideways, bring it to the center, and you see a slight curve, that would be the curve of the Earth. And what Jaron did is that he took a picture of his tabletop, which is absolutely flat, and shown that if you do the same thing and squish it, you would get the same result. Also took a picture of his computer screen with a flat line and shown that to be the case. You observe this curvature because of how lenses work, and that kind of is humiliating, I think, to these people who made these arguments, believing that they were proving the curvature. You see often as well that people claim they're seeing curvature in a balloon shot, that as it's leaving the Earth, it already has that curvature that you know for sure you cannot observe, which is an effect of the lens, and the same curvature remains when it goes up. So that can be already modeled. And what Aetius is doing here is just another way to do this. So he's saying that he found out that without refraction, the flat Earth and the curved Earth model did not match the photographs. So he's saying refraction has an impact. The standard Gauss K, he continues, of plus 0.13 to plus 0.14, makes the curved Earth model match quite closely to the actual images. However, as noted from my first email, this value is inappropriate near the ground. By using actual negative K values, the distant objects, mountains, would be completely hidden and the curved Earth model would be invalidated. Unfortunately, micro DEM doesn't allow for adding refraction to the no curvature option to see what the 3D perspective looks like for negative K values of, say, minus 1.2. However, one can surmise that such a concave refraction might likely closely match the actual photo-video images. One such example project I analyzed last year was from a YouTube video. Here's a link. This video has now been taken down as its creator came to a horribly incorrect conclusion about how much of Pikes Peak he was viewing. Refer to the micro DEM images below, which should be self-explanatory. The video was taken at 2:40 p.m. on November 23rd, 2017. The Fort Collins archive temperature reading is listed as 67 degrees Fahrenheit on that date and time. It's not known what height above the ground the temperature was measured. The location of the video was in the roadway ditch, closely mown, about 3 to 4 feet above the ground. The line of sight crosses the roadway pavement for the initial portion of the view. Under these conditions, the temperature gradient was most likely highly negative, which would correlate to negative K value of possibly -1 or lower. The minimal tip portion of Pikes Peak that shows in the curved Earth model view without any refraction would then be completely hidden. Nothing but the horizon would be seen. In fact, an incipient concave K value of only -0.053 causes this to occur. In contrast, the program default K value of more or less 0.14 shows more of Pikes Peak closely matching the photo, giving the impression that the Earth is curved. However, this simply shows that the model appears to be a good one, as long as the assumed standard Gaussian positive K value is valid. As noted, this refraction assumption is erroneous. Refraction effects over such long perspective distances are obviously much more complex than a simple circular curve equation, whether plus or negative values. Refraction is more likely a curvilinear path over peaks and valleys along the LOS. Keep up the great work on the front lines. You guys are selfless for investing so much personal time and money to educate the public. You are incredibly tough cookies as well, as the crap you have to take from trolls and journalistic hit pieces is atrocious. Kindest regards, MJD. Here are some of the images that have accompanied his emails. Shows the camera location in Fort Collins. Still image from the video. Curved Earth view based on standard refraction of plus 0.14 in micro DEM. Flat Earth view with no refraction. Curved Earth view with incipient concave refraction of -0.053. Pikes Peak vanishes. So these are the pictures that he has provided with these emails. One final point is that Aerius has responded to my latest email. He says, "Thanks for your quick reply and the offer for a conversation. I'm certainly open to that at some point, as it would be very interesting. I have no training or experience in astronomy. However, there's a critique about the supposed finite velocity of light in the book Man or Matter, written in 1950 by Ernst Leyers, a Ph.D. in electrical engineering, who expanded on the anthroposophy of Rudolf Steiner. The archive version is online here. Another link in the description. See chapter 17, where he states, neither has an actual velocity of light ever been measured, nor can light as such ever be made subject to such measurement by optical means, and that moreover light, by its very nature, forbids us to conceive of it as possessing any finite velocity." The chapter goes into the details of this assertion. Later in the same chapter, Ernst discusses the true phenomenon of refraction, which contrasts with the accepted scientific explanation. Also check out chapter 9, where he discusses the polarity of gravity versus levity. It's a fascinating critique on Newton's one-sided notion of a theoretical gravitational force of attraction. this topic is extremely relevant to the flat earth debate. My education and professional experience isn't electrical engineering, but civil engineering. A great deal of my work for decades has involved terrain analysis and drainage designs based on survey data over large tracts of land. Neither I nor our surveyors ever took into account earth curvature or standard refraction in our work. I vaguely recall the topic being quickly covered during a surveying class at university, simply to be cast aside and never used once I was in the workforce.
Can't say that it's refraction because the light goes like over the edge. Yeah, if you see what I mean. You can't refract the edge up higher because the light goes round the curve. You agreed?
Yeah,
the light goes round the curve, like the curve itself doesn't move, because that's a physical entity. So you can't make the curve itself. You can't make planet Earth bigger or smaller. So now we're seeing so it should be 1.22 miles away, but we can see it's actually behind that second platform. So it's about
behind that second, and it's behind the second platform, but it's probably further out because of atmospheric condition.
Yes,
and I'm saying, although the horizon is just an apparent line where the sky meets the ground, right?
Yes.
So even in the definition of the horizon, they discard that and give it an actual distance from the viewer's height.
Yes.
Calculable, right?
Yes. And in this case, it would be 1.2 miles.
Exactly.
It's the hard edge of the sphere. It's the hard edge, and you can see it's way further than 1.22 miles.
For the globe model, it has to be the hard edge because then objects start disappearing behind that edge.
Yes, and unfortunately, those platforms don't look like they're disappearing behind the edge. And the edge seems to be...
They're edging behind the disappearance.
And the edge seems to be more than 10 miles away. So it looks like planet Earth has got 5 times larger, overnight.
No,